Welcome to the Stakeholder Prepping Podcast video tutorial series. Today it's going to be Map Reading 101. We realized that in episode 15, when we went over how to read a map and land navigation, it's a little bit difficult to digest with just the audio. So we wanted to give you a visual representation of the steps involved in figuring out where you are versus where you want to go. I am your host. My name is Chris. I do not have AC with me today. We are geographically separated for those of you who are aware, and it's just easier to have one of us do the video presentation. So AC will not be joining us today, though he is watching the comments, so feel free to comment. Let's go ahead and jump in, get started. So for land navigation, we have our four basic components. We have our protractor, which also acts as our straight edge. It is plastic, so it is flexible. We have a pencil, something to mark with. We have our compass. This is a US issue, and you do see it does have the radioactive markings on it. That's because it has tritium in the dials, so they do glow in the dark. And then, of course, we have our map. And our map is really our most important piece here. If we look at our map, over on this right-hand side, and I'll zoom in here in just a moment, we can see all of the information about our map, where it was created, when it was created, and most importantly, in this case, who created it, MyTopo. We got these maps, it even says Stakeholder Prepping up there. We got these maps from MyTopo. It is waterproof paper, and it is folded. You can get them rolled, but these are awesome maps. I've used them before for several different things. We decided to go ahead and get this one for Stakeholder Prepping, as you can see here. But it even has its own unique map ID. And then if we go down a little bit further, we see our vicinity map. This is the state of Tennessee where I am. That little red square down there, that's the actual area of our map. If we go down a little bit further, we see our source map information. This may or may not be on yours. This map is actually comprised of these 6 maps. And it'll even give you the date of those maps. So 1983, 84, 84, 97, 84, and going all the way back to 74. Now we're going to get into some of the more important pieces here. So, on our map, we have our magnetic declination chart. And what these 3 symbols are, this is grid north. So all of the lines on our map are going to point to this grid north. Then we have our true north and our magnetic north. Now, true north is the North Pole. That's where Santa's workshop is. Magnetic north, that's where the molten copper, or the molten metal core, I should say, of the planet has its magnetic pole at. That does shift over time. Now, if you notice, this says magnetic north 0 degrees, but there is that little line there. So it's not a true 0. It's about half a degree, but it's less than what you can make out on a compass, so it's declined on the map. So every reading that I get on my compass, I can translate directly onto this map. I don't have to add or subtract any degrees from my declination. And this is as of December 11th, 2024. Now, we also have our scale. So this is a 1 to 50,000 scale. So for every inch represented on the map, that is 50,000 inches. And we can see here, this is a universal transverse Mercator, which is UTM, also known as MGRS, Military Grid Reference System. And we can also see here, 1,000 meter UTM, USNG, MGRS. So we know our scale. So every one of these squares over here is 1 kilometer by 1 kilometer. That means that these 100,000 meter squares, BD and BE, we can actually see that we change our grid. So up here you see BE and then BD, and it starts at 0, goes up, 99 goes down. So we know that if we had both the BD and the BE map, Or if we had BD and then CD going to the east, or AD going to the west, we can start to compile a complete map. These are all taken out of map section 16 Sierra, which is a massive area. You can see right there. So starting out, we know that our grid zone designation is going to be either 16 Sierra Bravo Delta or 16 Sierra Bravo Echo. So we have 100,000 meters plus or minus to work with. So let's go ahead and orient ourselves. Now, because we have no magnetic declination, when we do this, we know that we don't have to make any adjustments. So if we line up on grid north, and then we're going to twist the map and the compass together until they line up to pointing north. So you see I go too far, and if I come back, now we're lined up. So that is actually north. Now let's figure out where the heck in the world we are. I'm going to zoom out a little bit here. And we're going to move over. And let's say we recognize a couple of landmarks. So maybe from where we're sitting, we can see this lake here. And there's a water tank here. That's a water tower. So let's go with that water tower. Now, if I zoom in, really far in, you can see where my lake is and where that water tank is. And it's just a very, very small marking right there. So we know that we're in this general area. We can see this lake and we can see this water tower. I'm going to zoom out a little bit so you can see what I'm doing here. So that's a pretty big lake. You can see it's almost a half kilometer at its largest dimensions. So we need to focus on one point. I can pick this point, I can pick this point, I can pick this point, someplace where it's a defined area. So I'm going to pick this point right here, and you can see that little mark. And then I know I want to make my water tank. I want that one to be on the dot where it actually showed. And I can see both this corner of the lake and this water tower from my current position. Okay, so now I take my compass and I'm going to basically line up and point at wherever that lake is and get my reading. And I'm going to do the same with the water tower. So I know where my readings are. And let's say for this argument, let's say that when I'm looking at this specific corner of the lake, I'm getting a bearing of 261 degrees. So we want to write that down. And then with the water tank, I'm getting a reading of 10 degrees. So we want to write that down. And now we want to take that 261 and that 10 degrees and add or subtract 180 from it so we can get what's called a back azimuth. Now when we get a back azimuth, this is what's going to give us our X to show us where we are. So if I subtract 180 from 261, I get 81 degrees. Perfect. Now I can take my protractor and put it right on where I was measuring to. And now that I know all of this is lined up 100% straight, right? And you can use the compass to double check, because you can always line your compass up against that straight edge. But I'm going to mark off 81 degrees, which is right about here. Okay, so that mark, now I can take my straight edge and line up my 2 points and I'm just going to draw a line right through them. It's a very faint line, but you can see it. Make that a little bit bolder. This is why mechanical pencils, they're great for writing, but depending on what you've got, they may not completely cooperate. They are a very fine point, so you know it's exactly where you want it to be, but they can be a little bit hard to write on this waterproof paper. Great for navigation, and this waterproof paper from my topo is super tough. It's actually a lot harder to tear, but you may want to get something like a alcohol pen in order to actually write on it. These pencils just don't cut it. And grease pencils, while they're great for marking just about anything, they make too wide of a mark to effectively navigate by. So we've got our first line, and then let's take our second bearing, which was 10 degrees. Now we're going to add 180 to that, and we get 190. So I'm going to take my second point, which again was our water tank. I'm going to put this right on that water tank, line up, and double check our bearing. Okay, so I'm going to mark 190 degrees from that point, which is going to be down here, because again, we're going backwards. So 180, 185, 190. There's my second point. And we're going to do the same thing. We're going to take from our water tank right here down to the point we just made, and if we lose where it is, we can always double check. So we know the water tank is right there. There's our point. Just going to shift our straight edge around, line this up, and we're going to draw a line right through those two. Now, what we have done effectively is create an X right there. So you can actually see if those are the bearings and the landmarks that we're getting. Right there is our current position. Now, how do we relate that to somebody else, right? Well, we know we're in grid 16 Sierra, and according to this map, if we move this down again, we know that the 9899 BD, and then going into BE, so we know we're in the BD grid, Bravo Delta. If we go back to our spot, now we can go all the way to the bottom or the top, and we know that our particular grid was in number 44. So we are at 4-4, and then going up here, this one happens to be in number 9-2. So we've narrowed it down to a kilometer that we're in. So this is Bravo Delta 4492. That's still a pretty huge area. That's 1,000 meters by 1,000 meters. Roughly 100 yards. Let's see. That's almost 10 football fields long by 10 football fields across. That's a huge area. That's way too big of a search area to find somebody. So now we've got our point here, and we're going to take our protractor and figure out exactly where this point is so that we have a closer grid mark. So the way that we're going to do this is we're going to take this bottom edge right here and line it up on our grid line, and we're just going to slide it over until we find our point, which is right here, remember? So we're going to slide this over and line everything up. And now we're going to take whatever this shows, so 0, 1, 2, and it's a little bit over, so we're going to call that 2, 1. So now we can take this grid, the 9-2, right? So our 4-4-9-2, we're going to call this 4-4-2-1, and then we're going to write that down. And we're going to say 9-2-6-2. So now our new grid, this position is 16 Sierra, Bravo Delta, 4-4-2-1, 9-2-6-2. And that is a 10 meter area. That's about 33 feet by 33 feet. So you could park 3 to 4 cars in that spot. That's enough that you could call in an emergency medevac or call in for artillery or smoke or illumination. That's the standardized grid that is used in the military. If you've got an 8-digit grid, you can call just about anything into whatever position that you need to. But let's say from our new spot, so 4-4-2-1, 9-2-6-2, let's say we need to get up here, right? So we've got our new spot that we need to get to. What we're going to do is take our protractor again and just draw a line. And we want this line to overextend a little bit. So we're going to go past our point. You see this line continues up here. And then we're going to take our protractor and put this intersection right on our current spot and line everything up so that our grid lines match. And now we can take that line and see, oh, it's right at about 336, let's call it 337. So our new bearing should be following this line. Our new bearing should be right at 337 degrees, which if we look on our compass, let's get that lined up. 337 degrees, we're right about there. So we're going to pick a landmark that's in this direction. Following the pencil, it's going to go that way. We're going to pick some landmark out that way. And now we're going to go to that landmark and recheck every once in a while. But we can now effectively figure out where we are, where we want to go, and what direction we need to go to get there. I hope this was helpful. I know it's a lot to digest on a podcast without any sort of visuals. So that's why we decided to do this video. But as always, remember, you are your own stakeholder. We'll see you next time for the next video.